Hello, this is Case, and today I want to talk to you about the Nintendo 64 operating system. Basically, Mario 64 had its own operating system, which was later made obsolete by libultra, which is also Nintendo written. Now, what I have here is a nativized version of libultra. This was decompiled by someone else. Well, I say decompiled, but half of this is assembly code. The other half is actually C code. Surely we can find some. Yeah, right here, C code. So having this properly in my repo, instead of it being a binary file I include and extern the functions of, means I have a really easy time editing this, and we can do some proper compiler optimizations, which is very nice. Also, having this like this means we can easily optimize it, because some of the original libultra functions have as much as like 50% inaccuracy, redundancy, so like they're half as fast as they should be. For example, the translate function here. Let's look at the libultra one. Yeah, kind of like reading this. This is assembly. But this assembly is slower than the C code, trust me. Basically, like, you know, this just kind of writes a fixed point matrix. Very, very straightforward if you understand what's going on here. Then it just like writes all the zeros out like that, so not even in a loop. Writes some ones like this. It is not good, because it's all about code size on the N64. So instead what we can do is we have like our one identity matrix that is hopefully always cached, and we just copy it over. We only copy the first 14 elements of the matrix, because the 16th and the 15th will not be set to the same as the identity matrix. Actually, this, okay, maybe this is set the same. Either way, this one here is the big improvement. We invalidate the matrix memory, which means we save for cache reads, memory reads, which is awesome, because this means we halve the bandwidth. Plus, some of this is a little more efficient than what they did here. The code size in total is smaller. Code size is the #1 predictor of how fast your code is, along with memory accesses. Then another thing we can do is, if you look at exception. If you look at the exception handler here, this is one huge piece of handwritten assembly. And if you talk to a programmer, most of them are going to tell you that handwritten assembly is faster. But when an average programmer writes handwritten assembly, it is slower than when the compiler does. Especially if you don't really care about optimizing it. Which, okay, if you write handwritten assembly, why wouldn't you care about optimizing it? I do not know. Either way, this code was super slow. Without even understanding how the code works, just doing some common sense things already sped this up by like 10-15%, which is amazing, because yeah, the exception handler might run a bit, I'm not sure. I didn't even try actually, yes. But yeah, another cool thing is the VI manager. Having the VI manager in our own code here means we can nativize some Mario 64 functionality with it. Of course, also very cool. And lastly, one cool trick here is the memcopy thing. If you look at this, I do log where memcopy is called from. Why would I do that? Because memcopy sucks, and sometimes your compiler auto-generates a memcopy. We never want that. So whenever the compiler does that, I log it and I fix it. I remove every single memcopy call in my entire game. At the end, I want to remove memcopy from the repo entirely. But that would cause a bunch of compiler errors right now, so I'm not doing that. Also, it might just be that GCC would insert its own memcopy if it can't find one in my repo, I'm not sure. I do plan to make this public, of course, along with the ROMHacks release. I don't know if you can legally use this in a commercial game. I'm not sure how much I have to change it for that. I'm not sure if it's possible to change it enough to be that. Hopefully most of this whole stuff is going to be gone, because I feel like a lot of this is unnecessary bloat. But I have to probably look into that. So look forward to that, and I'll see you whenever. Bye bye.